Let me just start by sharing this picture. That was the last time our guest, Simon Heater, was in New York for, it was still an in-person conference. So here was an after the conference, it was a get-together where we had some beers and we were able to spend some time together. Looking forward to have that again. Right, let me just stop sharing the picture here. Thanks everyone for joining the NYJavaSIG tonight. Thank you for spending the time with us. I would like to ask you if that's your first time coming to the NYJavaSIG, and also where are you tonight? I would like also to thank our sponsors. We have here Agile Learner from the great Venkat Subramanian. So if you watch the presentation tonight, at the end, we're going to raffle a subscription that gives you access for 1 year to the Agile Learner. There's a lot of great content over there. And also, JetBrains is one of our sponsors. You can be the lucky winner of a license, a 1 year license to any of the JetBrains products. So our guest here tonight, Simon Reeder. There's no surprise after the picture. So Simon is a deputy CTO of Azure Systems. He's a Java champion. It was really great to have you with us past September 2019, if I'm not mistaken. And tonight, well, I think for you, it's almost a new day since you are in London. So thanks for taking the time to be here with us. He will be talking about OpenJDK and some of the new features of Java. I think a lot of developers are very excited for all the new things Java related. So we have a bunch of new things that came with this Java 17 release, like records, pattern matching, and we're looking forward to learn more about it from you. So without further ado, thank you very much again for joining us and that late. Simon, the stage is all yours.
Okay, great. Thank you very much. Right. Well, first thing I need to do is share my screen, find the right thing, and share that. Hopefully you can see my slides.
Yes.
So that's that. Let me just that and that. Okay, good. Right. So excellent. Yes, let me get started then. So the idea behind this presentation is as was described, to talk about what's new in OpenJDK 17. And really, obviously, we're not going to talk about just what's in JDK 17. We're going to talk about everything that's since the last long-term support release, which was JDK 11. So very logically, we're going to talk about JDK 12, 13, 14, 15, 16, and 17. So the first thing to talk about, as a little bit of an introduction, is that Java has changed, and it has changed a lot, I think we can say. And the reason for that is that we've seen since, let's see, JDK 9, that we now have this 6-month release cadence. Very different to the way things used to be. We had, 2, 3, even 4 years between major releases of Java. Since JDK 9, that's changed. We have very much a time-based release, and we know very predictably that every March, every September, we're going to get a new version of Java. And I think that's been very, very successful. And I have to say that in terms of the decision by the OpenJDK developers, I think that was absolutely the right thing to do. It's enabled us to move Java forward in a way that's much quicker than we've seen before. That has resulted in, obviously, 8 releases since JDK 9. I mean, that just seems incredible to think that we've had that many releases in that short space of time, but there we are. And as I say, it's enabled us to deliver more features more quickly than we've ever seen. So the sort of general speed at which Java is evolving has really picked up since we've made this change. So clearly that's working very well. Now, as I said, this session, we're going to explore as many of the new features as possible that have been added since JDK 11. I'm not going to cover absolutely everything because that would take a long time. I'm going to focus mostly on the language side of things. I'll talk about some of the major changes in terms of APIs, and I'll touch on a couple of things around the JVM, but not so much of the JVM side of things. Yeah, so the idea being helping you as developers to get ready for this long-term support release. And it's probably also worth just spending a moment talking about that. Long-term support releases are a concept of the binary distributions of OpenJDK. So it doesn't actually apply to the projects in OpenJDK. This is just about people who provide you with a distribution that you can install, whether that's Azure, whether it's Oracle, whether it's somebody else. And those people are saying, yes, we will continue to provide updates to it, we will provide support for it, but it's not a thing about OpenJDK. And what's also interesting is that Oracle, when JDK 17 was released last week, they made a proposal to change the speed at which we're seeing long-term support releases being made available. We have a 6-month release cadence for the JDK itself. And what they said was that initially there's 3 years between LTS, so that's 11, now we've got 17. What they want to do is change that and shorten it. So now we're only going to have 2 years between long-term support releases. Now the next one's going to be JDK 21. I think that's quite a good idea. Some people have felt that 3 years is too long, and all these great features that are coming through, they're going to have to wait too long because a lot of enterprises and commercial users don't want to use the intermediate releases. They only want the ones that have support. So moving it to 2 years is probably going to help with the adoption of the new features in the different versions. And one of the other things that we've seen in terms of having a 6-month faster release cycle is it's enabled us to do some clever things to help move the platform forward in a better way. First of those is what are called Incubator Modules. And this is defined through JEP 11, JDK Enhancement Proposal. What this is about is adding new APIs to the Java platform, but doing it in such a way that they are non-final, meaning that they could change, and in the worst possible situation, if people really don't like them, they could actually be removed completely. So they're not made part of the standard, they're not final until they've actually exited from being incubator modules. So very much about APIs and some tools as well. What the idea behind this is to allow people to provide some feedback. Clearly, the developers have a clear idea of what it is they're trying to do, but there are definitely times when the feedback from the people using this feature means that there might need to be some little changes made to it to make it even better to address the needs of the users. What we've seen is the first one of those was JDK 9. The support for HTTP2 was introduced as an incubator module. Nothing got changed in that, and then it was made final in JDK 11. So that's now part of the Java platform. What we've also got is the idea of preview features, again, defined by a JEP, in this case 12. And this is where we're talking about things that relate to the Java language itself, the JVM, and also JavaSIG APIs. And again, it's about having things which are new features, but making them non-final, where they can be changed. But importantly, it's not about introducing things that are like a beta. We're not trying to develop things as we deliver these things. It's about having fully formed, complete features. It's just if people think there should be some changes made based on how it's being used. So we'll see good examples of that as we go through. One thing to mention about preview features is that because they affect the language, and we need to maintain that write once, run anywhere compliance with the JavaSIG specification, you have to enable them. You have to tell both the compiler and the runtime that you want to use these features. As we can see here with the compiler, you use the enable preview flag, and you also have to specify the release that you want to enable those features for. With the runtime, you don't need to specify the release that's involved because that will be baked into the class files. Compiler can get that information, but you do have to enable those preview features if you want them to be used. That's just about the preview APIs. Sometimes the language features require changes in terms of the JavaSIG APIs, so that's why you see those included in preview features rather than being incubator modules. Okay. So let's start very logically with JDK 12 and see what features we got in that. Well, the first of those was switch expressions, and this is a preview feature. So as I said, subject to some change if we need to. The reason for this is that if we look at Java, the language, much of the syntax of the language was based on C as a starting point, and C had switch statements in it, which allowed you to switch on a variable and then do something based on what the values were. It's kind of like a if then else statement, but without all the extra code. Now that's all very good, but there are a couple of drawbacks in terms of making reliable code. One of the things is that you have to have a break statement in each case block. And if you don't, you fall through into the next one. That's the way it's designed to work. It's not a bug. But if you forget to put your break statement in, which I know I've done in the past, and I'm sure many other people have done, then you end up dropping through and you get a result which is not what you expect. And sometimes it can be quite hard to debug that kind of thing. Also, we have the issue of the scoping of local variables. Sometimes that's not totally intuitive the way that works. And also you've got to have each case statement being separated. So what they did in JDK 12 was allow a change in that. First of all, let's look at how this works in the way that we would expect Java prior to JDK 12. This is a very common pattern of use of a switch statement. What we're doing here is we're switching on one value, the day of the week, and then we want to set another value based on that. In this case, the number of letters. So our switch statement switches on day, then we do case Monday, case Friday, case Sunday, set the number of letters to be 6. In the case of Tuesday, number of letters is 7, and so on. As I said, we've got potential there for some bugs if we forget to put break statements in. But we also have a problem if we forget to set the value of number of letters in one of those blocks. And again, that could lead to inconsistent states and slightly hard to find bugs, which just makes our life harder as coders. In JDK 12, what we now have is a switch expression. So the first thing is to understand that when we talk about a statement executes a set of code, a set of instructions, but it doesn't generate a result. In the case of an expression, we execute a set of instructions, but we generate a result that we can assign to another variable. What this allows us to do here is to change the way that our code works. So now we have our switch expression, we switch on day, and we assign the result of that to number of letters. Immediately, that solves one of our problems, because now we've got one assignment, and we don't have to worry about assigning it within each of the case statements. We can see that the code is a lot shorter than the previous slide, and that's for a couple of reasons. First of those is that we now have this incredibly powerful feature, which is we can put all the case values on a single line, because it's taken the developers of Java 25 years to realize that there's a comma separated list. I never quite understand why it's taken us that long to do this, but there you go. And now we can do case Monday, comma, Friday, comma, Sunday. Great, all on one line. Wonderful. We've then borrowed some syntax from lambda expressions. We use the arrow operator. The right-hand side of the operator is the value that we want to return from the switch expression. So Monday, Friday, Sunday, 6, Tuesday, 7, and so on. What we see here is much more concise code, a lot less lines than we had before. As I said, we don't have to worry about the break. We don't have to worry about making the assignment within each case block. And the important thing here is we haven't lost any of the readability. If we look at that code, we can see what's going on. It's nice and clear. We don't have any difficulty in terms of understanding what's going on. So it's not like the previous slide was nice and easy to read. This one's really complicated and dense. Still very, very readable. What we can do is we can combine the old style syntax for the switch statement with the new style syntax in a switch expression. So again, we can take our switch expression, we can assign the value to number of letters, but this time we'll use the old layout of having case Monday, case Sunday, or case Friday, case Sunday, and lay it out on separate lines. But in this case, rather than using the arrow operator, what they decided to do was to use break with the value. So again, it sort of still sits in with the old style of syntax. Now this will work because what we're doing here is overloading the use of break. Now you can have break within a switch statement where obviously what you're doing is saying we don't want to fall through to the next case, but you can also use break within a loop and break to a label. Now, I must admit, I don't think I've actually ever done that in any code, but it's sort of like a go-to, and it does get used occasionally. In this case, we're also using break to indicate the value that we want to return from the switch expression. This will work because a label cannot start with a number. So we don't have any confusion in terms of the compiler trying to figure out, is this breaking to a label or is this breaking the value that we want to return? So that will all work and everything can compile. There's no confusion there. In terms of new APIs, one thing that I just thought I'd highlight for JDK 12 was a new collector that's been included in the Streams API. Streams obviously been around since JDK 8. Everybody loves it. It's really good. And what they've done is gradually add a few little things here and there just to make it that little bit better. In this case, what they did was add this new collector called teeing. And teeing takes 3 arguments. It takes 2 collectors and a by function. The effect of this, as you can see in the diagram, is take the input stream and duplicate it. So we now have 2 streams of identical values. We pass each of those through the collectors that we specify as parameters. We take the results of those 2 collectors and we use those as input to the by function. By function takes 2 inputs, generates a result. Easiest way to show this is in terms of an example. What I can do here is I can say, okay, let's take a stream of numbers, 145217, and then pass that into collect and use this new collector. So in this case, what I'm going to do is I'm going to say, we'll use teeing, and the first collector that I want to use as a parameter is summing double. That will take the elements on the input stream, 145217, and just add them up to give us a total. The second collector that I'm going to use is to count the number of elements on the input stream. In that case, it's going to be 6. So now I've got the total of the values on the input stream and the number of elements on the input stream. The by function that I then use is to say, take those 2 values, divide one by the other, and that will give us the average. Total divided by number of elements is the average. Obviously, I could do that with just a single method call, but in terms of just giving you an example of how this works, it's a pretty nice one that just makes it clear on what's actually happening here. So that's the way that it works. Obviously, you can make it more complicated if you need for different situations. Moving on to JDK 13. What do we get there? Well, we got another language feature, and again, it's a preview. Everything we're going to see that's introduced new to Java now is going to be as a preview feature. If we look at, again, the history of the Java language, we've always had the ability to create string literals. Very simple thing that we would do and very useful. What we would do is simply surround the string by double quotes, and what's in between those is our string literal. The problem has been that it's been difficult to include, certain special characters. We've had to use escape sequences or things like that, and also especially trying to make multi-line strings. You've either had to include escaped characters or you've had to do concatenation and things like that. Text blocks introduces a new way of defining a string literal. We've sort of stolen some of the syntax here from the Python programming language. So we use 3 double quotes rather than a single double quote to indicate the start of a text block. What I've got here is a simple piece of HTML. And so I've got some tags that I want to put on my web page. Everything between the opening 3 double quotes and the closing 3 double quotes, regardless of whether it's a special character or whether it's a new line, will be included in that string. One of the things about that is that we can then print out the result of that and see what we get. And we'll see that we get the tags that we've got there. And in this case, it's interesting to see how that works because the tags are aligned on the left-hand margin. That's probably what we wanted to see, but we've still got the indentation in terms of the tags that we see above. When we look at the source code, clearly what we've got is our tags moved over to the right. That's useful because if we had them all pushed over the left-hand margin, it would make our source code layout rather unwieldy. So by moving them over, we can keep everything nice and tidy in terms of the source code. So we can see that we've got the tags in the right place, and we can see that we've got the indentation that we wanted. And the reason we can do that is through what's called incidental whitespace. Everything up to the first character in our text block is going to be, or everything whitespace up to the first text character is going to be stripped out. But we don't strip out the other whitespace. So the incidental whitespace is only that left-hand margin. We don't just strip out every whitespace up to the first character, because obviously we would lose the indentation of the tags themselves. So there's a couple of other things to be aware of here. First is that when we have our 3 double quotes as the opening part of the text block, we have to have a new line after that. So we couldn't put the opening HTML tag on the same line. So it has to go on the next line. The other thing that we need to be aware of is that if we were to include some trailing white space, and in this case, what I've done is put 4 extra spaces after the closing HTML tag before the 3 double quotes, then that gets stripped out as well. Must admit, I'm not quite sure why they do that, but that was the decision in terms of what they wanted to do. One other thing to say is that if you did want to have 3 double quotes in your string, that's quite legitimate, quite valid. And the way you would do that is by putting a backslash and escaping at least the first one of those 3 double quotes. You could do the first one, first and second, third, doesn't matter, but you have to escape the first one. So that solves the issue of the layout of the source code and generating what we want in terms of our text block. Now, what we can do is, if we did want some more white space to pad out on the left-hand side, move the text over to the right, then we can do that by moving the 3 double quotes as the closing quote onto the next line and shifting it over to the left. What we're doing there is introducing some intentional indentation, which we can combine with our reduced incidental white space. Again, if we print out what the result of that would be, then we'll see that we get the HTML tags with our indentation, but now they're moved over to the right by the amount of intentional indentation that we want. So we have that flexibility in terms of how we want the text to be included in the block. One little thing about that is that because we put the 3 double quotes on the next line in order to be able to specify that intentional indentation, we end up with an additional blank line, which we might not want. I shall come back to that as to how we solve that problem. Switch expressions. Hang on, I've already talked about switch expressions, so why am I talking about them again? Well, this is an excellent example of where preview features has a powerful thing that it can deliver to us. What people said was, okay, you've said that we can combine the old style syntax of a switch statement into a switch expression. And now we can have case Monday, case Friday, case Sunday. And you said we'll use break to indicate the value that we're going to return. That's all fine. And yes, the compiler can differentiate between break with a label and break with a value. But as developers, we don't think that's great. We think it's a little bit confusing. What the developers of the OpenJDK did was they looked at that and the feedback, and they said, you know what, you're right. We will change that. And so in terms of JDK 13, now it uses yield rather than break. Now, this is one of the interesting things where what we're actually seeing here is the use of contextual keywords, because some people get a little bit sort of worried that is yield now a reserved word in Java? And the answer is no, it's not. So you don't have to worry about if you've used yield as a variable name, that will still be quite valid. Yield here is used as a restricted keyword, meaning that it will only work in terms of a keyword when it's used in this position. The compiler can figure out the syntax, it can figure out where it's being used, and so it will say, yep, that makes sense in terms of what we're doing. So we use yield rather than break. Moving on to JDK 14. What we'll find is that some releases have more features than others. Now, JDK 14, in my opinion, was one of those that had more good features, had some very useful things in it. If, again, we look at Java language and things that we've done in the past, often what we do is create simple data classes. We want to encapsulate a set of values so that we can pass them around as a single object. Very common thing to do in an object-oriented language. Classic example here is a point. It has two values, x and y, because it's a two-dimensional point, and we have a class. So to do that, we need to create a new class called point. Then we have to specify that there are two instance variables, double x, double y. We'll make them final. We then need a constructor, which will take two values as parameters, x and y, and we have to assign those values to our instance variables. And then we need two accessor methods, which will return the values of x and y. That's all good, but what we end up with is 14 lines of code to effectively create a tuple. So we've got two values, we want to encapsulate them, 14 lines of code. In JDK 14, we get another preview feature called records. Now what we can do is, rather than having those 14 lines of code, we can reduce that to one. We say record, point, and then we define in very much the same way we use the constructor, that our point is going to have two values that it contains, double x and double y. Now a record is really just a slightly special form of a normal class, in the same way that an enumeration is a slightly special form of a class. Because of that, we use the braces to indicate that there is a body associated with the record class, but in this case, we're not doing anything, so we leave that as empty. We can put it all on one line, and we've reduced that 14 lines of code into one. That's all good. The compiler will generate all of the extra things that we have on the previous slide automatically for us. We don't need to worry about the constructor, accessor methods, instance fields, all done by the compiler. So the first thing in terms of records is to understand that because they are like a class, they're just a slightly special form of class, then we can also use generics with them. We could do something like this. We can say record anything, and then we can specify a type parameter, generic type parameter t, and the thing that is going to be stored in our record is something of type t. Whether we want to use string or integer or color or whatever, then that's what we can use. So it becomes a generic record. The next thing we need to understand is that we can have a body to the record. We can add things if we want to, but there are some restrictions on what we can do. One of those is that we can't add additional instance fields. So if we specified in the case of our circle class here that we have radius as a double, as the thing that we want to store in our record, we can't then add some other fields that would be dependent on or specific to each record. What we can do is add fields if they're static. So long as they're static, we can add them, but if they're not static, we can't add additional fields. Here, what I've done is I've said, let's add a static double called pi, and then I've added an additional method called area, and that will simply return the value of pi times the radius squared, giving us the area of the circle. A few other additional details to understand about how records work. As I said, records are a class, but just a slightly special form of the class. And the way that that works is that all records inherit directly from java.lang.record. And what that means is that a record cannot extend a different class. It already extends record, so we don't have multiple inheritance in that way. So you can't say record extends, object, or I guess it does extend object, but you can't say record extends string. No, it's a final class. Record extends something else. However, what you can do is you can implement interfaces. So we can certainly implement as many interfaces as we want and then provide the implementation of the methods associated with that interface. Because we are a class. If we want to, we can override the standard methods that we have in object, because we do inherit ultimately from object. And so if we want to provide different implementation of the equals, the hash code, or the toString method, then we can do that in the body of the record. Records are implicitly final. So not only can we not inherit from another class because we're already inheriting from record, we can't then extend that record further by subclassing it. It is final, so no more subclassing. You can, if you want, add the final modifier to a record, but because it's implicitly final, you don't need to do that. It won't make any difference. Interesting thing here is that the records do not follow the Java bean pattern. What that means is that the methods you use to access the values of the record, the accessor methods, don't follow the pattern of saying get followed by the name of the variable, so get x or get y. The decision was made just to use the name of the variable as the method, so we have x and y. This is something that has been debated quite a lot. My personal opinion, I would have preferred to have used the bean pattern, but I respect the fact that the decision was made not to do that. One thing that this did have an impact on was that some frameworks and libraries, where they were using data objects and data types, wanted the Java bean pattern, so they wanted to use get x and get y. That was a little bit of a limitation in JDK 14 when this was brought out, because people said, oh, okay, can't use records directly like that. All those libraries and frameworks, or almost all of them, have now caught up with the idea of records, and so they understand that when they're using a record rather than just a data class, then they use the name of the variable as the method name rather than get x and get y. And actually, as somebody pointed out to me on Twitter, you can actually get around this problem, because you just say, well, okay, I'll create a record called point, and I should have put the type in there as well, so it should say double get x and double get y. I don't think I recommend this, but it is a way of actually doing it if you wanted to. Constructors are an interesting thing with records. So obviously, if we have our single line record, we don't have a constructor. The constructor is created for us by the compiler. It simply takes the parameters and assigns them to the instance variables. But there could be situations where you want to include some additional logic in the constructor. And you can do that a couple of different ways. What you can do is use the canonical constructor. And so this is the same as the constructor that you would have in a normal class, where you've got, in this case, a record called T-Rex, and we've said it's got two values, x and y. We can create a canonical constructor, which is T-Rex, and we specify the parameters that are being passed to it. We then have our little bit of extra business logic, or where we're testing to see if x is less than y, print out a message. But we must remember that we have to include the assignment of x to the instance variable and y to the instance variable. What we can see there is we're starting to lose some of the benefit of the record, because that verbosity that we got away from is now creeping back in. To get around that, the developers of records allow you to use a compact constructor. And in this case, what we can do is the same thing essentially. So we'll create a record called range that has a low and a high integer value. But now, rather than using the canonical constructor, the compact constructor has the name of the record, but we don't need to specify the arguments in brackets. We've got those on the line above, so why repeat that? We can include the extra logic, so test if low is greater than high, throw an exception, but we don't have to explicitly put in the assignment of low to this.low and high to this.high. That's, again, handled by the compiler. So the nice thing here is that you've got that simplicity and readability without including the extra boilerplate code. One thing to note here is that I've thrown an illegal argument exception, and that will work because it's an unchecked exception. Unfortunately, there's no way using either the compact constructor or even the canonical constructor to specify a checked exception. There's no throws clause that you can add to that. So with a record, you can't do that. If you want to do that, you have to be a bit more clever. So what you can do is you can say, okay, you can create another constructor. So you can have an overloaded constructor. You could have a record called T-Rex, which has int x and int y, and then you can create another constructor which has 3 values: int x, int y, and int z. Now, I know I said that you can't have additional instance variables within a record, but if you have a constructor like this where you're passing an extra variable in, as long as you don't use it for anything, then the code will work. In this case, because it's just a standard constructor, you can add a throws clause to that. This is getting a slightly more complicated, and I'm not recommending this as a way of writing code, but this is possible. So you can do that. You can then, you have to remember to put this x comma y to call the standard constructor on that, so that you get the assignment of the variables, and then you do your test and throw the exception, which is a checked exception in this case, if you really want to. But the important thing is that you've got to have the constructor signature be different to the canonical one. Like I said, I don't recommend this as a way of doing things, but it is possible if you really want to do it. And last thing to say about constructors in records is that you can include a default constructor. So even though we've specified values x and y for the record, if you want to, you can have a default constructor. So you can create a new record without any values, but you must then populate the values for the record directly from within the default constructor. In this case, what I've done is this followed by 2, 3. Not quite sure how much value that is, but there may be situations where you want to do that. Instance of. Again, if we look at the history of Java, what we'll find is that we've always had the instance of operator. The reason for this is that being an object-oriented language, we have inheritance and we have hierarchies of types. We may pass an object reference to a method and it's a particular superclass, but we don't know what specific subclass it is. We can test it using instance of and determine which particular subtype it is. This is a very common piece of code. We say if obj instance of string. So we're testing to see if our reference is a string. If it is, what we then have to do to use that reference as a string is to create a new variable, string s, and then we have to assign to that our obj reference and do an explicit cast to make it a string and let the compiler know that that's what we want to do. Then we can reference s and we can call the methods on that as if it was a string, because it is a string reference. That's what we do every single time that we use instance of, because if we want to reference that object as a string, we have to do the explicit cast in the assignment. In JDK 14, we get another preview feature, which is pattern matching for instance of. In this case, the pattern matching we're talking about is not like regular expression pattern matching. It's patterns of a type that we're matching against and then doing something with that. The code that we have now is slightly simpler, because now we can say if obj instance of string, and then we also add the variable that we want to reference that object as if it is a string. So we'll say s. In the true branch of that if statement, clearly what's happened is we've evaluated obj and it is a string. So the scope of s is valid, and we can then use that without having to do the explicit assignment and the explicit cast. When we say print out s.length, calling length on s will work, scope is valid. In the false branch, because we've failed the test on the instance of, s scope is not valid because it isn't a string, so we wouldn't want to call methods on that. So we wouldn't be able to use s there, and the compiler would reject that. We can be a little bit more clever with this, and we can say if obj instance of string s, and then we can add an and operator and put a conditional on the other side of that as well. We understand that with the and operator, we will always evaluate the left-hand side, and only if the left-hand side is true will we evaluate the right-hand side. That avoids having to do additional work. If we evaluate the left-hand side, that's testing the type of our object reference against string. And if that's true, then obviously we can assign the value to s. S will then be valid on the right-hand side. We call length on that and test it against 0. So that will compile, that will work quite nicely. If we were trying to use or, that won't work. That's a compiler error. Reason being that we will evaluate the left-hand side of the or operator, and only if that equates to false do we then evaluate the right-hand side. If the left-hand side equates to false, we don't have a string, so we wouldn't be able to call length on s because s wouldn't be valid in terms of scope, and the compiler knows that, so it gives us an error. The way that scoping works is through what's called flow scoping, and sometimes you need to be a little bit careful in terms of figuring out what that actually means. If you've got a simple if-else statement, then testing for true, yes, you know that it is that of that type, and you can reference the variable name within that part of the statement. If it's false, then obviously you can't. But in this case, what we could do is we could say if, and then we invert the test. If not O instance of string s, we return. So the compiler will know at that point that we haven't got a string and we've returned. After that, the scope of s is valid. So even though it's not within either the true or the false branch of the if statement, we could use s as valid syntax or its scope until the end of that method. So that will, with a block of code. So that will work quite happily. Text box, second preview. Again, seeing the value of having preview features that can have changes made to them before they become final. What they did here was look at the way things had worked in the past in JDK 13 and say, oh, 2 new escape sequences would be very useful because they solve the 2 problems that I showed you earlier. First of those is that if we want to determine that we've got some intentional indentation as well as our incidental white space, and we move the 3 double quotes onto the next line, if we don't want a blank line there, what we can do is simply put a backslash at the end of the line, and that will tell the compiler that we don't need the new line on the end of that line. This is very similar to if you've done shell script programming or make files, then the backslash as a continuation is very common. Similarly, if we don't want to have the compiler strip out space on the right-hand side of our string, the trailing spaces, then we can actually use \s to indicate that this space should be included in the string that's generated from that. So again, that's a nice simple way of solving that problem. Foreign memory access API. So this is one of the library changes introduced in JDK 14. And the idea behind this is part of a bigger project, which is Project Panama. Project Panama is designed as a replacement for JNI so that we can interact from Java with native code like C or C++ compiled libraries. Part of that is memory access, and it's also related to things like sunmisc unsafe, where people want to have access to memory outside of the Java heap. If you want to use direct byte buffers and do various things like that, then this is the way to do it. So we have the idea of the foreign memory access API. There's a number of classes involved, but 3 of the most significant are a memory segment. So what that represents is a contiguous area of memory that we want to be able to access. It's essentially a pointer to an area of memory. We then have a memory address, which is a pointer to an individual address in memory. So rather than being a block, it's addressed to an individual address. Can be on heap, can be off heap. And then we also have the idea of memory layout, which is where we can take our memory segment, which is just an area of memory, and then we can specify the description of how we want to be able to use that area of memory when it comes to storing values in it. So a couple of examples of that. Simple one is that we want to create a memory segment, which is an area of memory, so we can actually allocate some native space. It's kind of like doing malloc in C of 100 bytes. What we can then do is loop through that area of memory that we've created, and we can set values at specific points there and allow us to say, okay, set the value of an integer at each 4-byte boundary and just populate it with values. If we want to, we can use memory layout, like I said, by describing how we want to store values in that area of memory. And we can combine that with var handles, which were introduced back in JDK 9, if I remember rightly. Simplified access to structured data. So what we do here is we can say, okay, let's create a sequence layout, meaning that we're going to have a sequence of elements, and that's going to be integers. So we do a memory layout of sequence, and then we're going to have 25 values because we're storing in, in 100 bytes. So 25 values. The layout of those values is going to be 32 bits in width, so typical integer. And then we'll also specify the ordering of those bytes within that. So we're going to use the native order of whichever platform we're running. What that means is that if the platform uses most significant byte first or least significant byte first, then it will use whichever one the platform uses. If we wanted to force it to do something, so we wanted to say compatibility with a different machine that we were sending to across the network, then we can force it to use least significant byte first or most significant byte first. But in this case, we're just going to use whatever platform order is. Then in order to access that, we can create a var handle to it. So we'll take our layout, create a var handle based on the int that we want to use. So that's our 32-bit value, primitive int. And then we'll say that we want path elements as a sequence element. Then what we can do is have a try with the resources block. So we're going to allocate the memory for our 100 bytes that we want for the layout. And we can then loop through that, and we can actually specify that we want to store our values in there, but we don't have to calculate the offsets directly. We don't have to figure out the 4-byte boundaries. That will be handled for us by the method calls that we're using there. So it might look a little bit complicated, but this actually solves a lot of problems when it comes to handling sort of memory off heap. Helpful null pointer exception. This is one of my favorite features, certainly from JDK 14, if not since JDK 11. If you've written Java code, I think there's probably, if you've written more than a few lines of Java code, there's probably no chance you've never had a null pointer exception. And the problem with that is that sometimes it can be a little bit difficult. We have something like this, a.b.c.i equals 99. So we've chained together a set of references. We get a null pointer exception there. What we're going to see when we run the code is exception in thread main, null pointer exception, line 5. Great. Okay, so it's on line 5, but does that mean that A is null, so we can't reference B? Is B null, so we can't reference C? Is C null, so we can't reference I? So then you're faced with, okay, use the IDE, use the debugger, maybe separate the line up, maybe put print statements in, however you want to do your debugging. But it gets complicated. You've got to do a bit of extra work. Don't really want to do that. So now in JDK 14, we get this. We get exception in thread main, Java lang null pointer exception, cannot read field C because a.b is null. We immediately know a.b is the problem. So then we can track back and go, well, where did a.b come from and why is it null? And then figure out how to solve that problem. The only drawback with this particular feature is you have to turn it on. Now, I guess there may be a reason for this. And the only thing I can think of is that if you were potentially parsing error messages and you weren't expecting to see that cannot read field C because a.b is null, that could confuse things. But I think that's a very unlikely thing for people to do. So surely turning it on by default would be better than turning it off by default. And then in order to turn it on, you have to use the command line flag, which is show code details in exception messages. It's got to be one of the longest flags we've got in Java. Couldn't they have made it a little bit shorter? Anyway, it's very useful for solving problems of null pointer exceptions. JDK 15. Again, let's look at how Java works as a programming language. We are object-oriented, so again, we can have class hierarchies and we can specify inheritance relationships. In my example here, I've got shape as a superclass and I've got 3 subclasses, triangle, square, and pentagon. Now, the drawback that we have here is we have no way of controlling who can inherit from shape. The only thing that we can do to control that is to mark it as final, which means that nobody can inherit from it. But we're restricted in only being able to do that. Now, why we might want to have more control over that is, for example, I create a shape class and I have my 3 subclasses, triangle, square, and pentagon. That's all fine. I'm using that. Somebody else on my project that I don't really talk to very much looks at my code and goes, oh, shape, I like that. I'm going to use that in my code because it'll save me some time. So off they go and they include that in their code and they subclass it and their code works. I come along and I think to myself, I need to improve shape. I need to make some changes to it to give it more pizzazz. And I make those changes and I make sure that triangle, square, and pentagon still work in exactly the same way. Problem is that the person who's borrowed my shape class and subclassed it doesn't know that I've made those changes. So when they come to run their piece of code, suddenly it changes the way that it works. They don't know why that's happened because they weren't aware of the changes. If we could somehow restrict who could inherit from shape, then we could avoid some of those problems. And that's what we get in JDK 15. We get sealed classes. Again, preview feature. And what it allows us to do is very logically say that we can control who can subclass a given class. You can think of final as being the ultimate sealed class. And one thing that's quite interesting about this is that it's called sealed classes, but it also applies to interfaces. When I saw this, I thought to myself, well, wouldn't it have been better to call it sealed types? Because that would cover everything. And I kind of posted a thing on Twitter about this, and David Delabas from Oracle came back and he pointed me to a discussion that had been had on one of the mailing lists. And it turns out that what I hadn't realized is that an interface is actually a form of class in Java. So it's an interface, but it is still a form of class. So they decided to call it sealed classes rather than sealed types. So it does apply to interfaces as well as classes. In terms of using this, the important thing is that all the classes involved must be in the same package or module. So they have to be reasonably closely related in terms of where you put them in your source code layout. How this works is by adding some additional modifiers and clauses to how we define a class. We've got our class shape, and we can then add the modifier sealed to indicate that this is a sealed class. So we have public sealed class shape, and we add a permits clause to that to say that the permitted subclasses are triangle, square, and pentagon. And then the rest is all just normal Java code. The compiler will then allow triangle, square, and pentagon to subclass shape, and everything will compile quite happily. If somebody were to come along and say, I like shape, I want to use that, I'm going to create a circle, then the compiler will reject it. It will say, no, sorry, that's not included in the permits clause. You can't compile that code. So this allows us to have that control that we need to make our code more robust and more reliable. Now, in terms of the subclasses of a sealed class, we must explicitly state the inheritance capabilities of each of them. And there are 3 possible ways that we can do that. So very handily in my example, I've got 3 subclasses. We can look at what those 3 options are. The first of them is that we can continue to make the subclass sealed and specify further subclasses that are permitted from that. So in the case of our triangle, we can say public sealed class triangle permits further classes equilateral and isosceles, and it extends shape. The second thing we can do is we could stop any further subclassing. Same way that we've done before, we simply say class square is final. So nobody can then subclass it any further. And the third thing we can do is we can unseal it. We can turn off the sealing of that class and say, in the case of pentagon, public non-sealed class pentagon extends shape. This is kind of interesting here because what we've got is our first hyphenated keyword in Java. And again, these are context specific. restricted keywords. They're not ones that you need to worry about in terms of backwards compatibility. So for example, sealed and permits are still perfectly valid variable names. Non-sealed is not an issue because you can't use a hyphen in a variable name in Java, so there isn't any issue with that. But the discussion was quite long about whether we should use hyphenated keywords in Java, and the decision was made that if we want to continue to extend Java further, that this does actually make a lot of sense. So we use non-hyphen sealed as a way of saying this is no longer a sealed class. Records, second preview. Now, what's happening here is a couple of minor changes again. Not always based on feedback from developers, but also things that the people who created records thought about afterwards. And so one of the things they changed here was to make the fields of a record to be really, truly final. Now, you might think that if the instance field is marked as final, then you set the value once and you can't change it. After all, there is no mutator method, there's no set method for records. You can't change the values directly. That's actually one thing that's quite interesting. So records are immutable, but only shallow immutability, meaning that the values that are stored in the record can't be changed because there's no access, there's no mutator methods, and there's no direct access. But if you have object references, then clearly the things stored in those objects can be changed because you can reference through the record field. Having said that, they're marked as final, but if you use reflection, then you can still, in other cases, change the value of a final field. With records now in the second preview, they've enforced that finality, so you can't change it even with reflection. If you try to do that, you'll get the legal access exception. The other thing they changed was a minor thing where they said that native methods are now explicitly prohibited. Because a record is a special form of class, you could use JNI, you could have a native method in there. That's now prohibited because they said that could introduce behavior that was dependent on external state. And really, records are about just consistent, immutable state. The other thing they did with JDK 15 and records, the second preview, was to add the idea of local records. And this is a really good thing. I like this a lot because now you can include a record as a local record within a method. It's implicitly static. And so what this has also done is mean that you can use local enumerations and even local interfaces if you really want to. What we can see here is a good example of why that's useful. So I've created a method called find top sellers. And what that will do is take a list of people who are selling things and a month that I'm interested in. And what I want to do is to order the list of people selling things by how much they sold in that month. Now, yes, I can certainly do that without a local record, but as we'll see, local record makes that much simpler. So my local record is going to be called sales, and it's a tuple. So it contains both a seller and some value of what they sold. What I can then do is take my list of sellers, create a stream from that, pass that into map, and map from the stream of sellers into my local record sales. And I do that by obviously using the seller from the input stream, and then I call a method which will use that seller and the month that I'm interested in, retrieve the amount they sold, and use that as the other value for my local record. Now I can pass that stream of sales records into sorted and sort based on how much they sold in that month. So now I've got an ordered list of sellers with the amount that they sold using local records. Now I pass that into map to unmap it, if you like, take the seller out of the local record and create a new stream of sellers, which is still ordered by how much they sold in that month. Collect that into a list and I get my result. So it just simplifies the code, and especially when we're dealing with streams like that, the intermediate operations can become much simpler because we can encapsulate more than one piece of data and generate a tuple in this case, and just solve the problem in a nice, simple, straightforward way. Another thing that they did in terms of the second preview was also to just basically state that records will work with sealed classes, or in this case, sealed interfaces, because records can't extend another class. So we can have a sealed interface called car, which permits interfaces red car and blue car. And so we can then have record red car and record blue car, which implements car, and that will work quite nicely. JDK 16. Pattern matching instance of. So there wasn't much in terms of language changes in JDK 16. In fact, there wasn't really any changes other than to say that pattern matching instance of and records became final. No more changes after JDK 16 to those two features, unless it was through modifications to the standard. For records, they didn't change anything between 15 and 16. In the case of pattern matching instance of, they made two minor changes to how things worked in the past. First of those was to say that the pattern variable, so like our S when we're doing object instance of string S, is no longer explicitly final, meaning that you can modify if you want to, which I think was probably a good idea. The other thing they said was that it's a compile time error to compare an expression of type S against a pattern of type T, where S is a subtype of T. You have to read that a couple of times to figure out what it actually means. And the easiest thing is to show you an example. I've got a method called print colored point. It takes a rectangle as an argument. What I've then done is I've said if R instance of rectangle, and then we assign that to our pattern variable, which is rect, and then print out whatever that rect is. That makes no sense, because if we're passing in a rectangle and we say if R is an instance rectangle, that's always going to be true. It has to be by definition. It is a pointless test. And now the compiler will tell you that, and it will say, nope, that's an error. Type rectangle is a subtype of expression type rectangle, because obviously it is. And so that won't let you compile. Stream toList, again, API changes in terms of JDK 16. This was just a small thing, which again is just to sort of tidy up some of the code in terms of streams. Obviously, we've always had the ability in streams to collect into a list. So there's a toList method on the collectors utility class, which you pass to the collect method. So, okay, that's fine, collect toList. Now, rather than doing that explicitly, where you say stream.of123 collect collectors.toList, you can do stream.of123 toList, and that's it. So it's just a shorthand for the above. Just, again, little tiny change which just makes life simpler. Period of day. Another thing that I picked up on that is one of those small changes in terms of the APIs that is quite beneficial. In the way that we format the time of day, we can specify various things and we can ask it to tell us whether it's AM or PM. Now we've also got a more descriptive way of dealing with that. And we can say something like this: datetime formatter of pattern, and then we use capital B. I guess they're running out of letters for this because capital B doesn't really seem to have anything to do with period of day. And then you do format local time dot now. And if you run that, what you'll see is in the afternoon or in the evening or at night or in the morning. So it's a more descriptive idea of what time of day it is. Vector API. So this is a slightly bigger piece of functionality that was included in JDK 16. And this is an incubator module in the same way that the forum memory access API was an incubator module. As I explained at the beginning, these are ones where, again, we can take on board changes before it becomes final. First thing about this is don't confuse the vector API with the vector class. So it's not about a collection where we want to store things in the same way we would use an array list. What this is about is expressing vector computations. And vector computations are where you've got hardware that has very wide registers. And that really applies to pretty much any processor you would use nowadays. Very wide registers can have multiple elements of an array loaded into them, and then you can apply the same operation to all of those elements in a single clock cycle. So single tick of the clock, and everything happens. So it's essentially doing a number of elements in parallel. That's very good. It's very efficient for numerically intensive operations. But the drawback is that not all compilers can recognize where this is usable. So ideally, we wouldn't need this. Ideally, what you can do is have a compiler that's smart enough to spot where these things work and then just take the code and directly compile it into the relevant instructions. And in fact, with what we do in Azul Prime, our other JVM, we recognize a lot more situations where vector operations can be applied. So this vector API is less valuable when it comes to running on Azul Prime, just as an aside. The way this works is that we've got an array of values, 10, 14, 11, 8, and what we want to do is add 2 to each of them. Now, normally we would write a loop to do that, and we would do each one in turn, iterating through our loop. The idea of having a vector operation is, as I said, using a very wide register, and we can load up those 4 integers into the very wide register, have 2 added to each of those in a single clock cycle, and generate the results. How does this work? Okay, so if we look at a simple piece of code that is taking 2 arrays, and we want to add the value of the second array to the first array, but only if it's even. If we didn't have that conditional in there, most compilers would recognize that and they'd figure out, yep, let's use vector operations. The problem is that once you get a conditional in there, that throws the compiler off, and the compiler says, oh no, I'll just do it the normal way. And if we look at the code that's generated by that code without using the vector API, we'll see something like this. We'll see the red boxes, don't worry about all the instructions that are going on here, but the red boxes represent the big one represents the loop itself. And then the only performance enhancement that's happening here is that it's doing loop unrolling. So rather than doing 1 element per iteration, it says, okay, I've got an even number of elements, so I'll do 2 per iteration and then complete it in half the time. If we use the vector API, then we need to change our code. And it gets a little bit more complicated. There's a payoff. What happens here is we say, okay, same method. First thing we need to do is create a vector species. And the vector species is going to enable us to use the register in a particular way. What this says is we're going to use a species which is 256 bits wide. So we are tying ourselves to a particular architecture. We need to make sure there are wide registers of that size. And we're going to deal with integers. Then what we do is we have our loop the same way we did before, and we've got our conditional, but then within the conditional, we're doing a bit of extra work. So the first thing is we need to create a mask, and that's going to allow us to figure out where to put the elements within the register, because obviously we need to offset them by a number of bits. Then we create vectors from the array, which we're going to use. So we need a vector for the array A, and we need a vector for the array B. So we do that using int vector and the from array method, pass in the species, which is the register that we want to use, the array that we're interested in, the element that we're interested in, and the mask that we're going to use for where to put it. We also need a third vector called C, which is going to be the result of the operation we want to do. So we take our vector A, and remember that we want to add that to vector B in the case where we've got an even value. Then what we want to do is extract that value out at the end. So we say vector C into an array, and we then can pull that out into the array A, and that will then populate it with the results that we need. If we look at the code that's generated from this, it looks a little bit different, looks a bit more complicated. But what we're seeing here is loop unrolling, plus we're using the vector instructions now. So rather than doing it just in the normal way, we've got the use of the AVX2, in this case, instructions, and we're also being able to do loop unrolling as well. So more efficient use of our code. For linker API, another incubator module, and again, related to Project Panama, related to the idea of the foreign memory access API. So foreign memory access API is about off-heap memory. This is about how do we link to foreign functions that are written in C or C++ and in an external library. How we do that is through this kind of code. Now, what I will say is that this looks quite complicated. And when they finally include the JExtract command, which is again part of Project Panama, a lot of this code goes away. You get a nice static import, and then you can just reference it through the handle, and it's just much easier to do. Until that, we have to do a little bit more extra work. So the first thing we do is we need to get a reference to the linker, which is how we're going to find the function that we're interested in. So we'll use clinker.getInstance, and now we've got a reference to the linker. Then we need to look up where we're going to find that function. So using the linker, we need to tell it where to look for the function that we're interested in. In this case, we're going to use the default lookup, library lookup, meaning that we have access to all the functions that are available directly in the operating system, so system calls and things like that. If we wanted an external library, we could do that as well. So we could do a library lookup based on an external library. In this case, we're just using the standard system call type interfaces. What we then want to do in this example is to be able to reference the get process ID function. And to do that, we use our linker and we create a down call handle. There are down call handles and up call handles. Down call handles is where we're calling from Java to a native function. Up call handles are where you've got a native function that needs to do a callback to a Java method. So we can do it both ways. In this case, we're calling getPid, so it's a down call handle. So we look that up based on the name of it. So it's getPid, and then we get the reference to it. And we also need to specify the types involved. So in this case, what we're doing is we're going to be using ints, because obviously there's an int that's returned from getPid, which is the process ID. And so we have to say that the method type is one that returns an int, and the function descriptor is a clinker with an int. So it's ints on both sides, a Java int and a C int. Then all we have to do is say print out getPid.invoke exact. So we invoke the getPid, which invokes the foreign function system call, get the result back and print it out. JDK 17, bringing us right up to date, literally last week. First thing here is pattern matching for switch. We talked about pattern matching for instance of, now we have pattern matching for switch as well. The reason for this is that when we look at the switch statement and even the switch expression introduced in JDK 12, what we have is limitations on what we can actually switch on. We can do switches on integral values, we can do switches on strings, and we can do switches on enumerations. In pattern matching for switch, that's been extended so we can now switch on a type as well. So very similar to the way the pattern matching for instance of works. Look at an example of that. I've got a method called type tester. I pass in something which I'm calling an object, so it could be any type of reference. And then I can switch on that. And now I can specify what I want to do based on its type. I can also include null, because null is one of those kind of special cases where we might well want to have a catch for that, or a case for that. So we do case null, print out as a null type. Then if we want to look for specific types, we can say case string. And if it is a string, then we've got a variable s that will be assigned that and explicitly cast to a string. We can print out the value of the string. We can also do the same thing with color. So if it is a color, we can have a reference C, which will be explicitly cast to a color. We can then call the method getRGB on that because it's valid, so it works. We can also deal with primitives in the form of arrays. Even though a primitive is not an object reference, an array of primitives, ints, is an object reference. So we can say int array and then have IA, and we can print out the length of IA in the right-hand side of our arrow operator. So interesting as well that we now use the arrow operator not just for a switch expression, but also for a switch statement. Remember, we're not returning a value here, so we can actually do print line on the other side. And we've also got default for anything that isn't one of the above. which also brings us to completeness. This is quite important. I could have something like this. So I've got my type tester again, and I go switch on O, and if it's a string, I want to print out S. If it's an integer, I print out what the value is. Great. That won't compile. And the reason it won't compile is the compiler will not know what to do if the type of O is not a string or an integer. To solve that, obviously what we do is we add a default clause. So we say default, where it's not a string, it's not an integer, print out some other type. However, we don't always have to use a default. We don't have to have a default in there. How can we get around that? Well, we need to be complete. And we can do that if we use a sealed class. We use our previous example of shape, which has 3 subclasses. We can say we're passing in a shape. And so the compiler knows that there are only 3 possible subclasses of that: triangle, square, and pentagon. If we specify all of those in the switch statement, then the compiler knows that it's complete and there's no issue with something else sneaking in there. So it can deal with all the possible situations, and that code will compile and run. We can use what are called guarded patterns. So this is also similar to what we saw with the pattern matching instance of, where I said that we could use the AND operator and have a conditional on the right-hand side. So what we can do here is we can say case triangle T. So we need to make sure it's a triangle. If it is a triangle, we can then have on the right-hand side of the AND operator a conditional which says call the area method on T, we know it's a triangle, and test to see whether that's greater than 25. If both of those things are true, then print out it's a big triangle. Obviously, we need a situation where we've got a triangle, but the area is not greater than 25. So in that case, we can also have case triangle T on its own. So that will match against any triangle. And if we haven't found a big triangle, we'll say, okay, it's not greater than 25, so it's a small triangle. And then we've always got square and we've got pentagon. So a guarded pattern is essentially the primary pattern for the type and operator and a conditional and expression. Compatibility issues. So it's worth understanding a couple of things that have changed between JDK 11 and JDK 17 from the point of view of migrating applications. Nothing terribly difficult here, just things to be aware of. First of those is in JDK 14, the CMS garbage collector was removed. And what that means is if you were using CMS in JDK 11 and you try and run your application on JDK 17, the flag for CMS won't work. So that shouldn't be a problem. You know, you should have been using G1, or you should have been using Azure Prime to get even better garbage collection performance. JDK 15, similarly, the Nashorn scripting engine was removed. So if you were using that in your code to run JavaScript from Java, then you will actually need to provide that as an external module, which you can do. It's not a problem, but you need to do it as part of your build process. JDK 17 removed the experimental ahead of time compiler and JIT compilers that were included back in, I think, JDK 14, might have been JDK 13. So those were removed. There wasn't a lot of interest in that. This sort of related to the Graal project, and what Oracle have decided is that they want Graal to be separate from the JDK or OpenJDK, so they've removed those from there. Last thing to mention here is also that in JDK 17, the security manager got deprecated. So it hasn't gone away yet, but it did get deprecated. And some people seem to be a bit confused by this, and they think that removing the security manager from Java is going to make Java less secure. That's not the case. The security manager in this case is the one that has been used primarily for applets. Applets ran in a sandbox because they were running on a browser typically, and you didn't want them to have access to the underlying file system, network connections, and so on. So the security manager was designed to allow you to grant access to those things in a controlled manner. Because we're not doing applets anymore, in fact, the applet API has also been deprecated. They've deprecated the security manager. There are some issues around this. It's not a done deal yet. There's some discussion going on about how this might affect some pieces of code, but expect to see that removed at some point. Last thing to talk about in terms of compatibility is the encapsulation of internal JDK APIs. This was something that started in JDK 9 when modularity was introduced. The idea was to turn off access to all the APIs that were non-public, the ones that you weren't supposed to use to write your code. Problem was that lots of people had used things like sunmisc unsafe, so if they just turned it off in JDK 9, it would have broken a lot of code. To get around that, they introduced a flag, illegal access, which had 4 possible values, and by default, it was allow, meaning that when you ran your code, and if you were using those internal APIs, you got access to them by default. JDK 16 changed that, so the default became deny. So it turned off access by default, but you could still turn it back on again by specifying illegal access on the startup line and saying set it to allow. JDK 17 has completed almost strong encapsulation. So now the legal access flag doesn't actually do anything other than issue you with a warning to say it doesn't do anything. What that means is that the internal APIs, other than the critical ones, are now not accessible. You can't even turn on access to them. Critical APIs, of which I think there are 9, are still accessible. And so there's this handful of APIs, including sunmisc unsafe, which need to remain there because of backwards compatibility. At some point in the future, all of those will get some form of public API. Sunmisc unsafe, some of that's already being handled by like the foreign memory access API, which allows you to do off-heap access. And so once all of that functionality is replaced with a public API, those will disappear completely as well. To summarize then, one thing I'll just spend a moment talking about what we do at Azul in terms of providing builds of OpenJDK. We have Zulu, which is our build, our distribution, and it's essentially an enhanced build of OpenJDK, fully TCK tested. We support older versions. We go all the way back to 6, 7, 8, 11, 13, 15, and now obviously with 17 just coming out, we also support that as a long-term support release as well. We have wide platform support, Intel 64-bit versions for Windows, Mac, and Linux. If you're still using something like Windows XP, then we've got 32-bit versions for Windows and Linux. We also have some other flavors, things like Solaris, we have MIPS, we have Solaris, Spark, and Intel, MIPS, ARM, 32 and 64, PowerPC. It is very much a drop-in replacement for Oracle JDK. We've had literally hundreds of customers who've done that, haven't had any compatibility issues. You can just change your JDK, your JVM, and off you go, run the code in the same way. TCK testing is great. To conclude then, 6-month release cycle, I think, is working very, very well. We can see lots of interesting language changes, keeping the language itself fresh, addressing these sort of rough edges, pain points that developers have, simplifying things like switch statements, making it easier with switch expressions, records, great idea, wonderful for doing data classes and things like that. Some things I haven't been able to cover in this presentation, things like change to the JVM in terms of some of the bits that there's hidden classes is one of the things that was introduced, but that's more of an internal thing. And as I say, if you're interested in using Java OpenJDK, please do have a look at Zulu. There's both a free version and there's also a commercially supported one if you want the updates within an SLA, if you want people to ring up and ask questions of, then that's all available. And the last thing I will just mention, because this presentation is part of what's called our Fujay Jug Tour. And Fujay is a website that we've started with the idea of providing lots of information about the OpenJDK. Fujay stands for Friends of OpenJDK. Great site, lots of resources. There's lots of blog entries on there. There's all sorts of things like details, all the command line flags, then the differences between different versions. There's details about security patches that are available in the different updates and all sorts of information like that in a nice central resource. So I very much recommend checking that out, just having a look at it to see what stuff is there. And that's it. That's the end of the presentation part. So let me stop sharing my screen and then we'll see if we've got any questions. Hopefully we have.
Perfect. Thank you very much, Simon, for the presentation. It was a lot of things, a lot of changes. Before we jump to the Q&A, I just want to say that we will raffle 2 JetBrains licenses. So they're valid for any of the JetBrains products, 1 year subscription, and also a 1 year subscription to the Agile Learner website from Venkat Subramanian. So just stay tuned, stay with us. After the Q&A, we'll let you know the rules and how you can participate. So I want to call Neha, who will be doing the Q&A. Neha, you have questions?
I have a ton of them. wait for it. Okay, so can you comment upon the licensing terms that were announced last week?
Yes, I will comment on that. Okay, so this is Oracle announced last week the change from a 3-year LTS release cycle to a 2-year release cycle. What they also announced was that they were going to change the license that they use for JDK 17 and later. So that means there isn't any change if you're using JDK 8 or if you're using JDK 11. So only if you migrate to JDK 17 or later will this license have an impact. And what they said was that they now have a no charge terms and I can't remember what it's called now. So it's no something terms and conditions, no fee. That's it. NFTC, no fee terms and conditions. And it's essentially extending the free use of the Oracle JDK, because in the past, the more recent changes to the license meant you could only use it for personal use, like playing Minecraft, or for development use or demos and testing. What they've now done is extend that so that you can use it for internal applications for free. There are still some restrictions in terms of if you want to provide an application which includes the JDK, then that's still, and you charge for it, then you can't do that with the free JDK. The other thing they've said is they will provide free updates until 1 year after the next long-term support release. So that effectively means 3 years of free updates for 17. After that, it reverts to the old license, or the license, the Oracle Technology Network License Agreement, which would require a JavaSIG subscription. So there is a period of free use, and then it reverts to being charged for.
Thank you. Thanks a lot. Another question is, I think is there a use case for the old switch statement with break statements? I guess we saw one example, something similar, right?
Well, yeah. So this is where the use of break is overloaded and it becomes a little bit complicated. So if you're using a switch statement, you would still use break because you need to indicate where you want to stop in terms of the case statements. So in my example of setting the number of days, you need a break, otherwise you drop through and you set the number of days to a different value. So the break statement is still completely valid in terms of a switch statement, but where you would use or used to use break with a switch expression was to return a value, but that's now changed to yield. So yes, break is still used in a switch statement. And so it will compile old code. So that would work. I think that's probably the easiest way of saying it.
Yeah. So there's a difference between switch statements and expressions that we need to be aware of and how to use them.
Yes.
Yep. Okay.
Although, and I'm maybe thinking about it again as I'm sort of talking. Obviously, some of the examples I showed you with the pattern matching for switch. Obviously, you can use the arrow operator in a switch statement as well. So if you wanted to, you could replace the breaks with the arrow operator and then have it all on one line. But that would you'd need to refactor your code to do that. But break will still work. Okay.
Thank you. There was a discussion going on with string interpolation in Java. So Barry is asking, couldn't they do something under the hood to create immutable string on the fly with interpolation in the source code? Any comments on that?
Yeah, I'm going to steer clear of that one because I've seen the discussion on the mailing list about the string interpolation, but I must admit I haven't read all the details of that, so I probably just steer clear of that particular one at the moment. I don't know enough about it without looking at what's been discussed on the mailing list.
No worries. The next question we have is, can we clone a record?
Can you clone a record? Yes, you can, because because it is a class and it has values in it. You can clone it. There's no issue with that. Yes.
So I have a question. Like, while I was asking the question, I got a question. I heard records are not by default serializable. So since it's a data class, why is that a choice? Like, why not default serializable records?
Yes. Yeah, that's a good question, isn't it? Yeah, and I'm trying to think whether, because obviously serializable is only a marker interface, so it's not that technically a record can't be serialized. It's just that it doesn't have the marker interface on it. I don't know. Yeah, I'll have to look into that one. Why wouldn't you make, because as you say, I mean, if you're treating it as a data object, then why wouldn't you want to make it serializable? Yeah, I don't know. Sorry.
Good questions are coming up.
I talked about it as we were preparing for Java 17. It's because you could put all sorts of stuff in a record, since you can add things. So there's no guarantee everything in it is serializable. And now you've had an implicit contract that doesn't make sense. So yeah, it has to be opt-in for it to work.
Makes sense. Thanks, Jean. Okay. Another question is how to create a copy of existing records.
Well, I guess cloning it would make a copy, but obviously it's a shallow copy. So if you've got references to other objects, all you're copying is the reference to those objects. So there'll be the same object. You just have two records pointing at the same instance of an object. So you could clone it, or you could do a deeper copy, but you'd have to write code to do that.
Okay, thank you. The other one is the usefulness of null pointer exceptions seems to be a no-brainer. Is there a reason why it wasn't introduced earlier? Maybe helpful and null pointer exception cause a performance hit? That's a good one, performance hit, yeah.
I don't see that it would be a performance hit because it's so simple. I mean, like, I'm thinking about it off the top of my head, but the JVM knows what generated the null pointer exception. So it knows that it couldn't, in my example, it knows that the reference from B was null. So it's not that it has to do any additional work. It's tried to track from A to B to C, and so found that B was a null reference. So it couldn't go to C. So there's no overhead in terms of the work it has to do. All it's doing is just letting you know that that's the point it reached when it generated the null pointer. So I don't see any performance hit from that. Why it wasn't introduced earlier, a very good question. I mean, that would have been wonderful if it had been introduced back in, I don't know, JDK 1.1, for example.
It would have saved a lot of time for a lot of developers.
Think of the millions of hours it could have saved.
I bet there's no one who hasn't faced null pointer exception. That I would meet someone. I would want to meet someone if he hasn't seen a null pointer exception.
Yes, absolutely.
Okay.
Just as an aside, that's the only time that you hear the term pointer in Java is null pointer exception.
Right. That's a good one. Okay. The next one is foreign memory access API affected by garbage collection?
Well, depends. And I say that in the examples I used, no, because we were referencing memory outside of the heap. Garbage collector only works on memory inside the heap. So if you were using the foreign memory access API to reference memory in the heap, which would be an unusual usage of it, but so then it would be potentially impacted by garbage collection. But if you're outside of the heap, then no, because the garbage collector doesn't work on that.
Okay. Then there's an opinion question. Will there be a point where Java becomes unwieldy because it has too many features?
I don't think so. I mean, again, opinion. I think that if you look at the way that people like Brian Gertz and John Rose and Mark Reinhold have sort of stewarded the language features and the JVM over many years, I think they've done an extremely good job of enhancing the language, but not making it radically different to the way it has been before, and kind of pushing it in directions that really sort of make it less appealing to developers. I use JDK8 as a great example. The introduction of a way of doing functional style programming through Lambda expressions and the Streams API. That was a really well thought out change to the language, because it did shift, to a different style of programming, but it did in a way which, when you see lambdas to start with, they look quite foreign because they've got the arrow in there and it's kind of weird. But it doesn't take long to get used to that and figure out, oh, right, that's how it works. So I think they've done an extremely good job of kind of making the changes so they address the needs of developers, but without kind of making radical changes. So a lot of the things we've seen there are just, taking those sort of little bits where people go, oh, that's really annoying. Why does it have to do it that way? And kind of making it smoother in that respect. So I don't think there's a point where, well, certainly not in my lifetime.
Makes sense. The next one is from me, actually. So you introduced the toList method. Is that unmodifiable? And if it is, then can you comment upon the difference between unmodifiable list and immutable list? Because we are seeing these terms a lot.
Yeah. No, I don't believe the toList produces an unmodified one, because there are actual specific methods to do that. The difference between unmodifiable and immutable is that you can't change the elements in the list, but immutable would indicate that you can't change any of the values. So again, it's this shallow immutability in that the list can contain a list of objects. Those elements in the list cannot be changed, but the values of the things that those elements point to can be changed. So we don't call it immutable because it isn't strictly immutable. The things can be changed through the references, but it's unmodifiable in the sense that the list can't be modified.
Okay. The last one, okay, I have to check more, but the other one is any news on when we will see previews for virtual threads and value types? I guess it's Project Loom and Valhalla. Yeah,
Project Loom and Valhalla. I would expect Loom will be included fairly soon. I don't know how soon is. I'm guessing, my guess, just as a guess, because I don't have anything to do with the development of this, maybe a year to 18 months. So let's say 3, we could possibly see some of Loom by the next long-term support release. I think that's probably quite achievable. Valhalla, I was just reading an update that one of the developers had written on that today, and we're still quite some way off, I think, Valhalla, because it's a big change in terms of what's going on. There is Jet 401, I think it is, and I think we'll see bits of Valhalla come through. Certainly the idea of being able to use primitive types in generics is probably going to be the first thing we see. Again, I'm kind of guessing, but from what I've read and what I see, I would expect to see primitives in the way of collections, for generics, would be something we'll see more quickly than value types and some of the other things that Valhalla is predicting. But I still think we're a bit of a way off Valhalla. Okay, thank you. I'm just verifying if I missed anything. There's another one which says, regarding Project Loom, I think, any memory model concurrency changes? I don't think there's any change in the memory model, but the concurrency, obviously, the use of depending on whether you call them virtual threads or lightweight threads, that will have an impact on how concurrency works in the JVM. But I'm not aware of any changes to the memory model that are required for that. Okay. There's a question from Frank. What does Simon's shirt say? Oh, AC/DC. AC/DC. One of my favorite bands.
Nice. I guess we are finished with the questions.
Perfect.
Yeah, I think it's already very late for you. So thank you so much for staying up so late.
Yeah, that's fine. It's 1:10 in the morning here, so that's fine. I have enjoyed this. I would love to be there in person. It would be great to come back to New York and do another in-person event.
Perfectly. We would love to have you again in New York, and we need to take that picture again with the new members.
Yes.
If I remember, I think the last time Ray paid the bill. So let's have him again. Let's not forget to invite him.
That's true. Yes.
Be sure to follow us again. NYJavaSIG on Twitter. That's where we notify about our future events. So please follow us. Our website where you can find all the information. And here, since we're on YouTube, hit the subscribe button to get notification on future events as well. We will have 2 events in October. So we should have the next one on October 13 about Kubernetes. And also by the end of October, we should have another event on quantum computing. So go follow us and to get notified about our events, right? Thank you very much for being with us tonight. I hope you have a great time as we had. Have a good one. Goodbye.